Hey everyone, so in this video, I want to talk about your next take-home assessment, GuitarHero. So like usual, you can find the specification on the course website. So this assignment is going to be implementing some classes that let you work with sound. And what your goal is, you're going to end up simulating a guitar, but maybe kind of a weird guitar, one with 37 strings. So this assignment has two main parts. The first part is implementing a single guitar string, and the second part is then implementing a class for a guitar that uses the guitar string such that it can simulate a guitar with multiple strings. So one thing I want to highlight, I mentioned briefly in the lecture video, was that this assignment is a bit challenging because it's kind of conceptually difficult to understand how the things you're being asked to do end up making sound on the computer. And that is not part of our learning objective. You don't need to understand why the numerical operations we're asking you to do ends up making sound that you could hear on your computer. We have some description of it in the specification, and that's more useful for context of kind of what we're trying to ask you to do, but we don't expect you to understand how the sound stuff works. Okay, so that's the important thing. So you might find this assignment challenging because reading the spec might be a little hard, since it might be hard to wrap your head around why this is making sound. Again, you don't need to understand that. So I recommend reading the spec a couple times to understand the overall picture, but really we tell you exactly what steps to do. And if you follow those, you'll end up with a working implementation that makes sound. So at a very high level, when you're first going to be starting off, you're going to just be implementing a single guitar string. And on that guitar string, the way we're actually going to implement it is with a queue of numbers that we call the ring buffer. We're going to be using this thing called the Carplett-Strong algorithm to simulate how the sound decays on a guitar string over time. So what you're going to do is you're going to make this queue of numbers that we show you pictorially here. And every time you pluck a string, it gets initialized with random numbers, kind of showing this kind of random amplitudes. Then what you do is at each point in time, we simulate the sound decaying by removing the first number and averaging it with the second in the queue, then multiplying by some decay constant and putting that new average number at the end. So every time you're removing a number and averaging it with the next number in the queue, and then putting this new average number back. So the queue always stays the same size at the end of each time that time ticks. You always remove one number and add a new number back in. So this is the Carplett-Strong algorithm. And magically, if you just keep running this algorithm over and over again and look at the numbers, you could use that as an interpretation of sound. And that's what our code that we give you does. It makes sound based off these numbers. Again, you don't need to understand why this ends up making sound. All you need to understand is that this algorithm just tells you to average the first two numbers and removing the first, and then putting that new average number times a decay constant in the end. So that's going to be the first part of your assignment. You're going to be implementing a guitar string class. The guitar string has some constructors to help you set up this ring buffer. And then it has three methods that you'll be implementing. One called pluck that fills the ring buffer with random values. Then tick is one step of the Carplett-Strong algorithm. So it's doing this one picture where you're going from time t to time t plus 1. And our code will be calling tick many, many times to kind of simulate the guitar or the guitar string decaying over time. And then also the sample method lets you look at the number at the front of the queue. Okay? So we tell you a couple implementation details, particularly how you're supposed to do some of this math and set up kind of your queue. One thing that is important is that, or one thing that's a little bit difficult with guitar string is knowing what to comment, what's an implementation detail and what's not. So you may assume that the client is familiar with the idea of a ring buffer in your guitar string comments. It's a kind of a weird decision, but we're going to say it's totally fine for you to be talking about the ring buffer. The client will have an understanding of that, but don't tell them how you implement it. Okay? So that's the first half of your assignment. Once you have that done, you should be able to do a couple things. So first, we have a file called test string that tests your guitar string, so that can help you out. And also, we provide this file called GuitarHero. And GuitarHero lets you play a guitar. Now, it starts off with this thing called Guitar Lite. I'll talk about guitars in a second. But we provide Guitar Lite for you. And once you run this and you have a working guitar string, you should be able to press the keys A and C to play music. So this is using the guitar string you will write. Okay? So that's the first half of your assignment. You're just implementing guitar string. For the second half of your assignment, you're actually going to be implementing a guitar. So we define an interface called guitar that defines what methods you need, namely to play a note or to check if it has a string, and also to pluck that particular string. Okay? You can actually see we already implemented we implemented a class that implements this guitar interface called Guitar Lite. You can actually look at Guitar Lite as an example of what kinds of things these methods need to do. Now, Guitar Lite is much simpler than your Guitar 37, the thing you're going to be implementing, because it only has 2 strings. What you're going to be implementing for your assignment is Guitar 37, which is a guitar with 37 strings, which maybe is more like a piano, but we call it guitar. Now, what you'll find is that Guitar Lite is a really good reference for what types of things you need to be doing for Guitar 37. But note, there are going to be some differences because Guitar Lite only has 2 strings. It kind of simplifies some of the code. Your code is going to need to work with 37 different strings. Okay? So we have some implementation details here about how you set up what this class is supposed to do in terms of setting up the different guitar strings in there, and also some details about how you should actually be writing this class. Okay. Now, once you have a working Guitar 37, you can actually change in GuitarHero, change Guitar Lite to Guitar 37. Oops, 37. No, this is one of the things that makes interfaces really powerful is we don't have to change the rest of our starter code. You just have to change this one initialization. And then when you run this, you're able to use most of your keyboard as described in your spec to play a song. So let's try this. So kind of fun. So some students really love spending some time maybe learning how to play this little keyboard piano and playing songs once they get this working. So that's one way to test your class. We also have this folder called Test 37. To run it, what we want you to do is copy Guitar 37 into that there, and then run the Test 37. You need to copy it because we want to have these other support files here that aren't with your other stuff. A much simpler way to run this is actually on EdStem. So EdStem, you can't use the sound stuff. You have to run on JGraphs if you want to listen to sound. But this run button on EdStem actually runs Test 37 for you. And you don't have to worry about doing any copying or anything like that. You just press run button and it'll show you the output. Now, when I press the run, I accidentally opened up letter inventory. Whoops. Go back. Take home assessment 2. My bad. It's the same. It looks the same though. When you press the run button, it will run the Test 37, and you don't have to worry about copying. We do all that for you. Okay. So what I was just saying is that on EdStem, you can't actually do any of the sound listening, so you have to download JGraphs if you want to actually play music. But then when you press the run button, and right now it's like a compile because I don't have any this implemented on Ed. One thing that you might find useful is that there's usually a lot of output in this Test 37, and it's sometimes hard to spot where your output might be different than what we expected. So what we have actually on the course website, on the take-home assessment page, is an output comparison tool. What this does is and we'll be using this for many of our other assignments, this has a way for you to select, what output do you want to look at? And here's the output for Test 37. And then you can paste your output. Now, note, my output doesn't have any real output because I just had a compiler error. But you could press compare, and it will show you line by line differences. Now, this output's not extremely useful right now because I'm nowhere close to having this have a working version. But you'll find that this tool is actually really helpful. If you only have a couple lines that are different, it points out exactly where they are, what we expected and what you expected. So hopefully you have this as a much simpler way of debugging and spotting if there's an error. It might be a little hard to figure out what's the bug just looking at this, but at least this helps you find kind of when we tell you what key we try to play, we saw a difference. Okay. So we recommend trying to make sure Test 37 runs and works before trying to use the provided test with the mark button, because those can sometimes be a little bit harder to spot kind of what's wrong. So one last thing I want to show you, just is a little bit fun, is once you have all this working, you can play guitar on your keyboard, but we also provide a class called Play That Tune. And if you run this, we actually, part of this assignment comes with a lot of different songs that students have written, and you can actually play them. Cool, right? And if you want to make your own songs and record them and share them, you could use the Record That Tune program. It will save a song into a file like this. And so if you want, please feel free to share some songs you write on the discussion board. Other students might enjoy playing them or listening to them. And so we hope you have fun with this assignment.